Now it's our session one. In session one, we are going to have 4 speakers, and after their speeches, there will be a 30-minute panel talk. Everyone in the webinar can type your questions in the QA box directly. Now, let's have our first speaker, Professor Filippo Fabrochini. Filippo is a professor in the College of Design and Innovation and the director of the Sustainable AI Lab. He is also affiliated to the National Research Council Italy. Please join me in welcoming Filippo. Filippo, okay. Now you can share your screen. Yeah.
Sure. Give me a second.
Yeah, sure.
You see my screen now?
Yes, perfectly.
Okay. So let's enter immediately into the main topic of this conference. Quantum Tales means quantum imagination. And quantum computing is going to be, in the next future, the platform on which most of the AI applications will run. It will be a revolution from a political, social, and economic point of view. It will be a revolution because we are going to conjugate or associate 2 powerful ideas, 2 powerful concepts. On one side, the concept of quantum computing, and on the other side, the concept of AI. My talk has been inspired by 2 papers of mine. The first one, you can have a look at the paper, together with Professor Tersidis and Professor Lee, has been published on a journal called AI and Society. And as you can see, it's basically a philosophical paper. But let me move to the second one. The second one has been already accepted and is going to be published on a journal called Journal of Neural Networks. Probably the Journal of Neural Networks is the most important journal today concerning artificial intelligence. You can see it's a very technical paper related to quantum neural networks, which are a sort of neural network architecture that can run on quantum platforms. But let me start with my talk. Here you have an exemplar of a crooked coin. And I guess, it's just my guess, because the coin has been completely deformed. Probably a coin of this kind has been baked in an oven. Yet you can think a cheat might easily alter a coin to prefer one side over another. In this case, a coin of this kind will be a biased coin. Yet, surprisingly enough, a coin of this sort can still be used for generating fair results by, and this is the most important point, revising the rules of the game. We need to revise the rules of the game in order to make use of a biased coin of this kind. The next slide shows a physical implementation of the Turing machine. A Turing machine is not a physical device. It's an abstract machine. It's a mathematical formalism. Even though, as in the case of this picture, it can be implemented physically. The concept of Turing machine is a foundational concept in computer science. It's one of the most basic concepts, by the way, affecting fields, very important fields, theoretical fields of computer science, such as, for instance, computational complexity. But what was the question that Turing tried to answer when he devised the Turing machine? And the question is, what is a mechanical process? And we need to understand this question in the context, in the historical context of that moment. At that time, Kurt Gödel, one of the most influential logicians of the past century, already published his own theoretical results concerning the incompleteness theorems. And the work of Turing must be situated in this context. So he devised the Turing machine exactly when dealing with the undecidability problem. Let me say what an undecidable problem is. In computability theory, an undecidable problem is a decision problem. Decision problem is a kind of problem which can have just an answer of the sort yes or not. So an undecidable problem is a decision problem for which it can be proved that it's impossible to construct an algorithm that always leads to a correct yes or no answer. An example of an undecidable problem is the halting problem. It can be proven that there is no algorithm that correctly determines whether any arbitrary program eventually halt when running. Now, we said that the question that Turing was facing was a question of the kind, what is a mechanical process? When Turing tried to answer to the question, what is a mechanical process, he provided a very simple answer, something that can be done by a machine. And this answer brought him to explore the general notion of computing machine. So a Turing machine, as the one that you can see here, I said it's a mathematical model, an abstract formalism. A Turing machine is a mathematical model of computation describing an abstract machine that manipulates symbols on a tape, like the tape that you can see in the picture, according to a table of very simple primitive rules. Very simple primitive rules. A very simple device. Yet, despite its obvious simplicity, a device of this kind is capable of implementing any algorithm humans might devise, including algorithms working on a quantum platform. An abstract model of this kind, in other words, is able to implement any algorithm humans could devise. But now let me quote Turing himself. A computer would deserve to be called intelligent if it could deceive, says Turing, a human into believing that it was a human. And Turing basically is well known today to the most thanks to the famous Turing Test. I want to say something more. Turing has been always exercised a powerful fascination on my person for a number of reasons. First of all, because, yes, I am a computer scientist, but as well because I am a philosopher. And I guess that Turing was both a computer scientist and a philosopher. And moreover, I must add that he had a strong connection with one of the philosophers that I love more, one of the two most important philosophers, most relevant philosophers of the past century, Ludwig Wittgenstein. He was a student of Ludwig Wittgenstein in Cambridge University. Now, let me spend a few words describing the Turing Test. There are many versions, to be honest, of the Turing Test. Broadly speaking, the Turing Test is a test of a machine's ability to exhibit intelligent behavior equivalent to that of a human. The original Turing Test requires 3 terminals, each of which is physically separated from the other 2. One terminal is operated by a computer, let's call it A, while the other 2 are operated by humans, let's call them B and C. During the test, one of the humans, let's say C, is asking questions, while the second human, B, and the computer, A, provide the answers. If C could not reliably distinguish the machine from the human, the machine would be said to have passed the test. Therefore, the Turing test is a method to verify if a machine talking through a computer interface will pass as a human. But do we really know Turing's intentions when creating his machine? What was Turing's goal? So we said that the main question that Turing was facing was the following: what is a mechanical process? But actually, Turing's attempt was to substitute the question, can a machine think, with the question, is there any computer which will pass the Turing test, the test that I just described? But if we think about the test, well, the evaluator is going to judge just the behavior, the exterior performance of the machine. Is not comparing the processes going through the human mind or the human brain with the processes going through the machine. And therefore, most of the scholars think that basically Turing was a behaviorist. Now, my main thesis is that the standard view here, therefore the thesis that Turing was a behaviorist, if not even a supporter of the strong AI paradigm, is just wrong. And again, we should go back to the historical context. And if we go back to the historical context, then we should think that Turing abstract machine, together with Church lambda calculus, both of them, have been invented specifically to generalize the limits of any formal approach, including math. And I'm referring here, obviously, to the work of the guy there on the top of my slide, the incompleteness results, the incompleteness theorems coming from Kurt Gödel. But if my thesis is true, then the other thesis, the thesis according to which Turing was a behaviorist, is totally misleading. My point of view comes exactly from the discussion between Turing and Wittgenstein. In my view, Turing's main point is that our limited computational architecture continuously forces us, as humans, to offload cognitive tasks to mechanical routines. So what we are doing constantly is to offload what we are not able to support in terms of computational power. I'm talking here about speed and memory, to offload cognitive tasks to mechanical routines. Yet there is a residual that cannot be cancelled. And this residual is common sense. And as this expression says, common sense is a common knowledge, a sense that is shared by all humans. And I can bring forward some example. We always think that, well, it's common sense that an object is identical to itself. It's common sense to believe that objects do not change dimensions suddenly. And it's as well common sense to think that in between true and false, there is almost nothing. It's called the law of the excluded middle. Well, if there is something that Turing machines cannot do, is exactly this. They cannot emulate or simulate human common sense. So, let me go to this picture. Here in the picture, you have a team of highly skilled ladies working, we are around the 1936, for the Jet Propulsion Labs. And these ladies have been known as human computers. They were responsible for the number crunching of trajectories, fuel consumption, and other details that actually helped make the US space program a success. Well, Turing's ideas, and Wittgenstein's ideas as well, were certainly inspired by people of this kind. In Wittgenstein's philosophical investigation, we find a sentence regarding exactly his own student, Wittgenstein's student, Alan Turing. He says, I will read the quotation as it is, Turing's machines, these machines are humans who calculate. And one might express what he says, what Turing says, also in the form of games, linguistic games. In this sense, a Turing machine is a specific subset of the very large set of language games human beings can play. Okay? So, we should never forget something that actually is totally obvious. Proofs are used by humans. Algorithms are used by humans. Even as Lemmanovich said during the first edition of our Aiiii Art Conference, even as concerns art and design. Art can be a mechanical, algorithmic process. Design can be a mechanical, algorithmic process as well. And what Turing did was exactly to analyze this specific language game. Turing analyzed what a step in a formal system is by thinking what it is for, what we are going to do with it. And now let me go back to Turing himself. A second quotation from him. These results, he's speaking about Gödel's results, the incompleteness theorems, may be regarded as going towards a demonstration within mathematics itself of the inadequacy of reason unsupported by common sense. Here you have a key sentence, really a key sentence, showing the main point I already stressed. Gödel's incompleteness results, together with Turing undecidability thesis, show the limits of any purely formal approach, including math. If we take seriously the statement mentioned in this slide, then we should conclude that an artificial intelligence, an AI grounded on a purely formal system, has nothing to do with human intelligence. Besides the fact that the expression artificial intelligence is totally misleading. If there is something that AI is missing, is exactly common sense, a statement about which any scholar, or at least most of them, would agree. But now, let me move to a third paper. This paper has not been published, has not even been accepted. We have submitted this paper recently. And the title of this paper, as you can see, is Finally the Death of the Author. In this paper, Kostas and I have summed up a number of metaphysical implications coming from the advent of artificial intelligence. Our main thesis is that AI art is disruptive from a metaphysical point of view, to the extent that the human centrality is dispossessed by the recognition of forms of creativity different from our own creativity. In our view, the power of an artwork, and I should remember here, for reasons that will be clear in a while, an artwork is an object among other objects. Could be this boat, this table, an image, a cloud, whatever it is. An artwork is an object. In our view, the power of an artwork consists in allowing us to discover structures, patterns of reality, relations between beings that are mainly inaccessible to the most. But if we speak about the structure of the reality, the structure of how things are, we are speaking about ontology. Therefore, as I said just during my introduction, in this view, the artwork makes accessible the ontologically inaccessible. Now, if we take into account seriously the Turing test, together with its conclusions about the limits of any formal system, we should say that the power of AI art goes far beyond the mindset of the artist, its own intentions, its own goals, or the message he or she, whatever, intends to convey as conceptual art pretends. What matters is the outcome of the artistic creation rather than the process leading to that outcome. at least in the case of AI art, where the intention is measured as the output of actions, regardless of where they come from, whether they are human-based or not, to the extent that they show an intellectual accomplishment. The AI artist, in our view, disappears in the background. In this sense, the implied author of an AI artwork must not be understood as the mouthpiece of the AI artist, its spokesperson. And it's easy to show this. Think about the introduction of randomization techniques, as it happens in the case of genetic algorithms, or the emergence of unpredictable behaviors, as it happens in the case of neural networks. Both disrupt completely the relationship between the output embedded in the artwork and the mental process the artist is following. Whenever a neural network generates an unexpected outcome, maybe in an unexpected fashion, well, by definition, the neural network is going behind the intentions of its own designer. It's not by chance, therefore, that the title of our paper is finally The Death of the Author. But now let me come back to the case of the crook coin, because I didn't finish to comment about the relevance of a crook coin of this kind to this topic. I think it can teach us something really interesting. Now, usually we assume that tossing a coin, right, mirrors a Bernoulli distribution with approximately probability 0.5 of success. We toss the coin and we expect, let's say, head with a probability around 50%. But we said that a cheat can alter a coin to prefer one side over another, transforming the coin into a biased coin. However, as John von Neumann has shown, the coin can still be used for generating fair results by changing the game slightly. How? You toss the coin twice, and then if the results match, you start over, forgetting both the results. If the results differ, use the first result, forgetting the second. Now, the reason this process produces a fair result is that the probability of getting heads and then tails must be the same as the probability of getting tails and then heads, as the coin is not changing its bias between flips, and the two flips are independent, important, and identically distributed. I'm just mentioning a common sentence, a common knowledge in statistical learning theory, in probability theory, I should say. Yet, von Neumann expedient is changing the rules of the game. The practice itself of tossing a coin for deciding who is the winner and who is the loser. We are simulating a fair coin by using a biased coin. We are simulating a game by using another game. And yet, I should remember, simulation is different from emulation. We can simulate to be in pain. I can do it even now, maybe without any success. However, we cannot emulate the pain of someone else, reproducing, copying the pain of someone else. In the case of AI, the situation is similar. We are simulating human intelligence by making use of a completely different logical mechanism. And as Alan Turing said, is different to the extent that this mechanism is not grounded on the common sense, as in the case of humans. In this sense, the nature of the intelligence exhibited by AI and the nature of the imagination exhibited by AI is ontologically and epistemologically different from human intelligence, whatever the traditional vulgata proposed by the mass media about AI pretends to make us believe. Let me move to the conclusions of my talk. And I need to introduce the work of a philosopher, very well known, Immanuel Kant. And you will understand why in a few minutes. The influence of, by the way, all of this, you can find all of this, you will find all of these, my remarks, our remarks, in the paper that hopefully will be published soon. But I want to say the influence of Kantian philosophy has been huge along the last 2 centuries. I remember that a few months ago, a colleague of ours, Michael Lissack, delivered a talk about constructivism. Well, the first one introducing a form of constructivism was exactly Kant, with his own Copernican revolution. He introduced a form of constructivism according to which, even though things in themselves, the so-called noumena, exist and contribute to experience, they are nonetheless distinct and separated from the objects of experience. Therefore, the objects of experience are mere appearances, the phenomena. And the nature of things as they are in themselves is unknowable to us. This is the Copernican revolution that Kant introduced. In this view, the world, the reality, needs us, the humans, for coming into existence. Whatever entity is in the world needs to be generated and needs to be guaranteed by the human mind, as soon as thinking and being can never be considered apart from each other. Isn't it a very powerful form of anthropocentrism? The most powerful rejection of anthropocentrism and the most powerful rejection of the philosophical ideas embedded in Kant's Copernican revolution comes from a philosophical school of thought named object-oriented ontology. And the main idea of object-oriented ontology is that, let me drink 1 second, is that objects have an existence independent from the human subject, with a consequence that their ontological nature is not reducible to the relationship that they entertain with humans. According to the school of thought, if we define the objects only through the relationship that they entertain with the human subject, the essence of the object is reduced to those relationships. What is the therapy here? The philosophical therapy consists in avoiding the dualist division between subject and object for accepting a landscape made just by objects. We become objects as well, and the subject disappears. An ontological approach of this kind is a form of radical, very radical realism. In particular, the influence of Kantian philosophy, I want to stress, is the main cause of an unwarranted anthropocentric assumption that some of the distinctive features of human beings, whatever it be language, reason, speech, automatically make humans ontologically different from everything else that may exist beyond thought. Thus, all other beings become objects that can be accessed only through the human subject and therefore cannot exist without humans. It's the most powerful form of anthropocentrism behind the contemporary thought. Now, let me arrive at the last two slides. Here you have a quotation from a book still unpublished from Manovich and Aiiii, and I will comment about this quotation. What AI art is showing is that an AI system can exhibit, can show a creativity alien to human creativity, to the extent that simply it knows how to make use of the speed and memory characterizing computational systems. And the use of quantum computers in the next future could further scale up those possibilities. Now, a variety of studies have emphasized that most humans are not able to distinguish between an artwork generated by a machine and an artwork generated by a human. And the recognition of this kind brings to a conclusion, paradoxical, that in its own attempt to create a better human, humans have self-defeated themselves by creating a machine, and the machine is an object in the sense in which object-oriented ontology speaks about objects, that proposes modes of creativity in many contexts superior to ours, by exhibiting as well an artificial imagination different from the human imagination. And yet, the artwork produced by this object, an object itself, can act on us by generating a variety of aesthetically pleasing feelings. And it's obvious that a remark of this kind is consistent with the object-oriented ontology school of thought, insofar as this object characterizes itself as an active object with its own private life. At the very end, the AI artwork, the artificial outcome of an artificial intelligence, doesn't need its creator as much as a better me doesn't need me. And I'm sure that my friend and colleague Kostas will illustrate tomorrow afternoon a couple of experiments which show how very primitive, very simple, very elementary mechanisms, such as, for instance, the use of permutation techniques or the introduction of randomness, can bring surprisingly interesting outcomes. As Wittgenstein, the philosopher that I mentioned just a few minutes ago, noted, maybe human creativity is supported and finally shows up thanks to very primitive, simple mechanism of this kind. And then I can arrive at the quotation from Manovich and Ariely by saying, if simple, primitive, non-human processes can generate an aesthetic object, perhaps we are giving too much weight to the notion of human. Conclusions. First, the intention behind Turing's abstract machine is to show the limits of any formal system by carrying out an analysis of the meaning of what a mechanical procedure is. Second, yet, Turing analysis shows as well how much humans tend to offload cognitive tasks to mechanical routines because of the constraints coming from their own cognitive architecture. Limited speed, computational speed, limited computational memory. Human intelligence, including artistic creativity, as Manovich stressed during the last conference, the 2021 edition of this conference, human intelligence, including artistic creativity, therefore, is much more mechanical than what humans prefer to assume. Third point, what AI art is showing is that an AI system can exhibit a creativity alien to human creativity to the extent that it makes use of the speed and memory characterizing computational systems. And in the attempt to create a better human, humans, we must conclude, have self-defeated themselves by creating a machine and therefore an object that proposes modes of creativity, as I said before, in many contexts superior to ours, by exhibiting an artificial imagination different, totally different from the human imagination. Fourth point, the contribution of AI art, therefore, consists in removing, in deleting the role of the human genius from the artistic scenario by substituting the genius with its own product. Besides, even more important, providing an empirical proof of the philosophical assumptions behind the object-oriented ontology. This awareness, if we accept it, is supportive of an ontology in which the anthropocentric vision is finally defeated by the charisma emanating from an object that human beings traditionally call an artwork, and yet, in this case, is not a human product. And if you prefer, you can look at AI art and at my own speech as a call for sustainability, maybe something more than a call. AI and AI art are already a fact. And an event of this kind is going to change our position, the human position in this planet. Finally, I want to say an object-oriented ontology of this kind brings us to claim that rubbish at the very end is as much important as any human being. And this can appear a trivial statement today. It should appear as a trivial statement today if we think about the conditions of our planet today. Thanks for your attention.
Thank you, Filippo. Now you can turn off your PowerPoint. Yes.
Sure.